Hi everyone, hope you're all having a good day. If you've been following what's been going on with this project that I've been working on, so we're using something called open battery information to reset the lockout flags on these Makita batteries. So if you've, just a little recap of what's been going on here. So you've got these Makita power tools, and occasionally, probably out of no fault of your own, when you put the battery on the charger, you'll get this beep, 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 and the charger will refuse to charge the battery, the power tool will refuse to use the battery, and it seems your battery is broken. But a lot of times there is a fault, or there was a fault, or the management controller in the battery thinks there was a fault and set a lockout flag, which tells the charger and the power tool not to use the battery. So we've been using a tool called Open Battery Information to reset that flag. And if you watch one of the previous videos, we condensed, so the first one that we worked out a method on the Arduino Uno, and there's a Python application. There are other videos that cover this, so I will link those in the description down below. And in the most recent video, we were able to put the software required on this tiny Arduino board. It is by Adafruit. It is a Trinket M0, and we got it working in the last video. So after that video, I thought, well, this thing is so small, can't I just put it inside this charger case? So in this video, that is what we are going to do. So I'm going to take this and put this inside this charger case. So the first thing we need to do is let's open up this charger case and see what's inside. And I think, if I remember from having this open before, there's plenty of space inside, so we just need to just wire everything up. So I'm not sure that this applies to all of these Makita chargers. This was a cheap knockoff charger that I got off Amazon. It was just basically the cheapest charger that I got. The reason why I got this charger was to get this yellow connector, get a hold of this yellow connector so I could interface with the management controller in the battery. So this case uses these special screws. It is a security Torx bit. I'll show you this driver. It is a DT-10. It says it's a 2.7 millimeter star drive. So I'm not sure if all the battery chargers use the same screw, but this is also the same screw that is used in the Makita batteries. Also, if you have a need to take these apart, this is the proper tool. So we will dismantle this quickly. Ultimately, I would like to, and I've seen various pictures and comments from people that have taken this project further and have actually made the all-in-one solution that I am attempting to do right now and place the Arduino Uno in the battery charger case. And if you look on the GitHub website, there are some pictures of that, I think, in the issues section. So ultimately, what I would like to do, this will be for another video after we get this built. This is a Raspberry Pi. It's got the official Raspberry Pi LCD screen. This is a Raspberry Pi 4. I would like to put the Open Battery Python application on here. It's got a touch screen, so it'll basically be like an all-in-one type of appliance type solution. You'll have this, and then you'll have this connected with the USB cable, and that'll be your all-in-one solution. When you want to reset a battery, you just turn it on, it starts up, you just push buttons on the touch screen and you're done. And that would be the ultimate goal of, well, for this step of the project anyway. So taking this apart, you notice I've had this apart many times. I kind of know my way around this case. So you have two connectors. We have the connector going to the yellow connector on top, and we have the power cable that supplies the charging power to the battery. Then we have this AC plug. This is kind of cool because everything is put on with connectors. So I can just take this off, and then when we get done, I'm just going to route the USB cable through the hole that the power cable came into. I could probably remove this board if I want to, but I'm just going to leave it there. It's not in the way. This thing is quite small, and it'll just kind of float around in here somewhere, probably preferably up at top. So I will have to keep that in mind when we do the wiring. So let's get set up to do some soldering. So the next part is we need to wire this board up. And from the previous video, when we got this board programmed up, so this board is already programmed. If you would like the Arduino sketch that is in here, check out the link in this video's description to my blog site, and it's available for download. Or you can also check out the previous video where we did that. So essentially we are looking at, so this is what we're looking at for a schematic diagram. That's how this is going to be hooked up. So we have the Trinket here. We have these 4.7K pull-up resistors. Then we have the battery here. And this is just kind of a review from the previous video just to refresh our memories. So we have this here. We have the battery here. And we have our resistors here. And the goal is to get this connected up, and then we'll put it inside this case and close it up. And then we should have a very robust solution that won't just fall apart when you blow on it. Getting ready to solder here. It's got to protect my table. And I would like wires that are a little bit longer, so I'm going to strip these wires off. And in order to prevent, usually I can do this quick enough that I don't have a problem, but if you do overheat the pins here, and the pins will come out of the plastic on the connector, and then you'll be in trouble. So one way to help prevent that is to put the mating connector in it like this to act as a heat sink. And the wires won't be so prone, the plastic won't overheat as quickly, or what's the words I'm looking for? The wire, the pin won't heat up hot enough to melt the plastic and damage the connector. So what we're going to do, let me see if I can zoom in here. So I'm going to pull these two wires off here. So a lot of people usually ask what type of soldering iron this is. This is a Hakko. It's an FX951. I like it. It's has a digital temperature control on it. It heats up very quickly. I can change the tips on it. So this is the tip that I usually use. And you'll see it's got a curved tip on it. That's by design. And it just allows me to get a different, to get a better touch on components that I'm soldering. So let's pull these off quickly. So I'm going to heat this up and pull it off as quick as I can so that I do not damage these pins. Then I'm not sure how long I need this to be. So we're going to cut this wire and strip these ends. One of them looks already stripped, but then I'm going to pre-tin the wires. This is going to make it so that it is very easy to solder on. I'm going to pre-tin them so there's some solder on there. And there's also some solder on the connectors, so when we solder this on, it's just a matter of kind of melting the two together. Okay, and then I would like to cut these so that they are not too long. And usually with these kind of projects, I would put heat shrink over these connections that I'm making, but in this case, we're going to wrap the whole thing when we're done with it. I've got this high temperature tape. It's called Captain tape is another name for it. I think this stuff's rated for like 280 degrees Celsius. It's pretty high. And I use this sometimes when I'm using the hot air rework station, so I don't damage components on the board. I can cover them. But this is the sticky stuff on this stuff is also not gross like regular tape, so it does not get nasty over time. And the tape is rather thin too. So we will get these on this connector. Another reason to put these heat shrink on these wires when we're done is when you have a soldering connection like this, so what you've done is you've created a stiff part here where the solder's wicked in, and then you've got this stranded part of the wire. And over time, if this thing flexes and bends back and forth due to being dropped, shifted, moved around, this will fatigue over time and it will break off right there. And it's rather annoying. And the way to fix that is to put some tape or some heat shrink or something to kind of stiffen up this connection right here so that it does not fatigue and break off. So we're going to wrap the whole thing up in Captain tape when we're done, so it won't be too much of a problem to worry about that. And then we have the power connector. I think this thing's pretty big and beefy. I think I can just do this and pull this off quickly this way. So, I mean, you guys probably have things like helping hands. I have those, but sometimes tape is just easier to stick a piece of tape on something and tape it to the table. Okay, and then we will extend the wire, or we'll put a longer wire on it is what I should say. And we'll do the same that we did with the other connector and just mount the two together. Hold it for a second, and there we are. Connectors are ready. We'll get this out of the way for now. We don't need that. We do kind of need this. So another thing of concern that we might want to be aware of is that this red pin is going to have 20 volts on it from the battery, so you want to make sure that whatever is connected to this red line, and it's going to stick out of this connector right here, you don't want this thing touching or shorting on anything. We are going to 20 volts shorted out can make a nice light show. We'll tape this up when we're done, and it won't be a problem. So in our diagram, let's bring this back up. So we're going to lay out the components here. And so the battery goes like this, which means that the top of the charger goes like this. This helps you keep track of things. So go on like this, therefore that goes like that. And then we have two pins. We have our enable, we have our one wire, and then we have our ground pin, which is, where did that connector go I just made? Let's just put it on right now. Okay, so now we just need to connect this up to these. And then we have to deal with the pull-up resistors. But we're actually going to deal with the pull-up resistors first. So on our sketch, we used pin 0 and 2. Zoom in here. So on our sketch, we used pin 0 and 2. So we've got pin 0, we've got 2, we've got the 3 volt pin. So the 3 volt pin is going to be where we pull up our voltage. And I'm trying to think of a good way to do this because we have to squeeze the other resistor in here too. I think if I kind of sneak this in and wrap it around, You know, I think I'm going to go the other way. So I'm going to go from pin 2. There's a reason why I'm doing this way. I'm going to go like this, and then I'm going to loop it around. And then what this is going to enable us to do, bend this over, and I'm going to insert this resistor in here like this. So now we have a resistor between pin 2 and pin 3 in the 3-volt pin. And then I'm going to take this resistor, the second resistor also needs the 3 volts, and that is on pin 0. So we'll stick it in like this, and we'll bend it over, and we will solder it onto the top of here. Then both pull-up resistors will have access to the 3 volts. So that is what we are going to do. So I would first like to get this resistor soldered in place. And let's see how we're going to do that. Hopefully the lighting, not sure how to do the lighting here. Hopefully it's clear enough. I need to point it this way so I can solder to it. Well, this is hard to do. I think I'm going to tape this down. It does not want to stay put while I am soldering it. If you guys hear that beeping in the background, that's the soldering iron. When the soldering iron finishes heating up for soldering, it does a beep to let me know it's up to temperature. When I put it back in the holder, when I put the soldering iron back in the holder, it goes into a sleep mode where the temperature comes down a little bit to help save the life on the tip. Okay, so this is our first connection. I'm going to cut these extra wires off here. And that, I'm okay with that. So there's our first connection. That's between pin 2 and 3 volts. And then comes the one from pin 0. And this will connect in like that. So first I'll tack down this connection. I will get that from the bottom here. It's always a challenge getting stuff to stay still while you're soldering it. Okay, pin 1 is soldered in place. And then, I mean, I could probably loop this or do something, but I think I will just get it close. And we'll put a little bit of solder on these 2 wires here to get them connected together. Make sure that these wires, you don't want to overheat them, but you want to heat them up enough that the solder sticks well to both wires. Otherwise, you will end up with a cold solder joint. The thing won't work right, and it will be hard to trace down because the break in the connection is so small that it's hard to notice that they are not soldered together. Okay, Ooh, colors are backwards on that. Ooh, I'm kind of picky about that. I like everything lined up the same, but these parts are not polarized and it won't matter. I guess we'll let that go. Okay, so the yellow wires need to connect on 0 and 2. And then we have one more wire that needs to connect on this GND connection up here. And the GND connection is our black wire. So we need to figure out what wire goes where. And since I moved this thing around, double check the orientation. That's the correct orientation. And checking our diagram again. The top one is enable, which goes to pin 2. Then the other one goes to pin 0. So this pin, so let's locate this pin. Enable, it's the second one down. And this connector, like I said, for some reason, the vendor or the manufacturer decided not to populate this top hole. So we're actually after this wire. This wire comes out here. And this, so I wonder, now I have to decide, is this the length that I want these wires to be? I think they're a little long for my taste. So I'm going to trim these down. Careful, because if I trim these things too short, then I will have to put a new wire on them, and I would really not want to have to go through that. So we'll strip the insulation off these, and we'll get some solder. We'll tin these. So I always tin these wires first. It helps to solder them together easier, and you will not end up with a cold solder joint. So I kind of like to do that. And then, okay, we're back to our original issue of which pin is which. So this is the enable pin. And the enable pin, we said, goes to pin 2. And how do I want to do this? So I think at this point, I'm going to take these connectors off. It's going to be easier to do this with the connectors off, since I know which is which. So I can do this either like this or like this. So I think I'm going to do this like this and have the connector come off in this fashion. And then the ground connector, I guess, will come off here. We're going to tape all of this up. You know, I would have been smart if I kept these the same length. That's okay. We'll see what happens. Okay, so the enable pin goes on 2. So this goes on 2. And that's this resistor, which is this pin. So we're going to tack this wire. Let's zoom this in, see better what I'm doing here. So we're going to just tack this wire. This is a little tricky to do. We're just going to tack it onto there. If we heat this up, making sure we have a clean iron, and we should, this is hard to film and be able to solder at the same time. I'm just going to melt these two together. If I did that correctly, looks okay. There's no shorts. It does not look like a cold solder joint. And then, of course, the other wire will go on pin 0. So we'll tack that on. So we'll just heat these two up together and melt them together. There. So this is connected. They're not quite the same length. You know, I'm going to fix that. I would like these two wires to be the same length. So I'm going to remove the wire. We're going to shorten it up slightly. Yeah, it's just a hair bit too long, but that bugs me. Okay, back to joining these together. Ooh, that resistor's hot. Yeah, resistor got hot as I was holding it, so I didn't get enough heat on this, I don't think. So I'm going to heat it up and make sure it's got a good connection. All right, that looks nice. I mean, now that one's too long. I'm done. We'll just leave it like that. Okay, and then we're going to grab the ground connection, which is this pin. So we're going to find that pin on the back. It's already written ground. So on this one, we can kind of stick the wire in the hole and solder it like that. And if everything goes right, we'll end up with a nice looking connection here. It came out of the hole. Back in your hole. You know, this isn't going to work out. Tape. So you want to heat it up first and then put the solder on after it's heated up. We really want to apply the solder to the wire, not to the iron. We don't want the solder to go to the iron first. We really want the solder to go to our connection. If you'll end up with the cold solder joint. So the temperature I usually use for my iron is 300. I have it set to 320 degrees Celsius, but I'm also using this silver bearing solder. It's got 2.5% silver in it, and I like the stuff. It makes things shiny. I like shiny stuff. Okay, so this should be done. So now we need to tape it up and put it in here. So I'm going to grab my USB cable and get zoomed back out again. USB cable is going to go on here. And we will tape this up. So this Captain tape, this tape is really useful. You could probably find it on Amazon. This is high temperature tape. And you'll notice the thing I like, I don't use this tape only for high temperature applications, but it's nice and thin. The sticky stuff is not nasty, like other tapes become after a while. trying to figure out how to do this. So let's just start putting pieces of tape on it, and we'll trim things up in a minute. So I think the first piece of tape, I think what I'm going to do is I'm going to put the tape on here, and then when I get done, we will trim it up. So I want, let's see, I don't want this touching the table yet. Let's see if I can do this in a way that it doesn't. I'm going to put another piece of tape on it as well. And this tape's also good for insulating stuff, which is the main reason why I'm using it, is to keep everything insulated. And we'll put another piece of tape right here. This should be sufficient. Now remember, I told you we have our 20 volts sticking off this pin right here, but we'll put some tape on that. So now what we're going to do is we're going to turn it over, put some tape on the other side. So we are kind of taping our USB cable in during the process, so you kind of want to make sure you have the USB cable that you want to use for it connected. I'm going to trim this thing up when we're done anyway, so it doesn't matter if we're not exactly lined up. As long as we are close and everything is covered. Okay, ooh, that looks nice. Remember I talked about that metal fatigue stuff earlier. We won't have to worry too much about it because the connections that could flex back and forth are covered by tape. So now let's trim this up and make it look nice. I'm going to leave this as it is with the overhang. I think it's a good idea, but I'm going to get this sticky stuff off of this other side. There, that looks really nice. Okay, now we're going to deal with the connectors. So the connectors, ideally too, I will put some tape on. So now I'm kind of stuck with this USB cable pulling this board everywhere. I'm going to plug this guy in, and that's how that guy is going to stay forever and ever. So we'll tape that guy up. This one, I think I'll just wrap some tape around it. I mean, the other thing, I have some other tape as well. I have some, what do you call it, cloth tape. That works really well for this kind of stuff too. Although this stuff looks kind of nice. So we will just kind of wrap this up. So the other thing, like I mentioned, this is another fatigue point on this connector, is right here. So we want to make sure we get this taped up rather nicely so that those wires, those joints do not fatigue and the wires come off. Because then you got to open this thing back up and fix it. And then when it happens again, you open it up and fix it again, and the process just goes on. Okay, that is well insulated. Okay, deal with the ground wire. And when we put this on, you'll notice that there's a little bit of metal sticking out here too, so we'll make sure we tape everything up here. And I think there's got to be a better way to do this. This thing is pulling pretty hard on. So if I twist it this way, I will tape it up like that. So we're going to cover these metal parts here. And then I'll get a couple pieces of tape, or I'll wrap some tape on the bottom. You know, I kind of wish that I left this black wire a little bit longer, because this is kind of hard to deal with, but all right. It could be better, but it will work. So now, should we test it before we put it in the case? We'll just put it in the case. So I don't know how this is going to fit together, but we will find out. I think if I'm somehow able to do this, look at that. That fits rather nicely in there, doesn't it? Okay, I think we're good. So let's put this together. And I'm only going to put 2 screws in it right now, because if hopefully I don't have to, but if I have to pull it back apart, I don't have to take all 4 screws out. All right. Now we need to test to see if it actually works. Now, these LEDs and everything, obviously nothing's going to work. We've disconnected the power from this thing and everything. Okay, I need an extension cable. One moment, I need to grab a USB extension cable because I forgot. Okay, USB extension. My PC is a little bit further than I would have liked. That's just how it works out. I'm just going to plug this in. And if you look, we can see that board is working in there. See it? It's on. Okay, let's plug the battery in. Okay, so let's switch over to the PC now. I know we do have to check to make sure this thing works, right? Because it's not done until we know it works. I'm going to switch over to the screen capture. And this is the Open Battery the Python application. If you want to know how to install this thing and get it working, there are some links to the full guide in the video's description. Oh, look, you see the lights in there. In the video's description, so check out that guide if you would like to know how to get all this working. I've got a full guide on that. Do we connect? We connected. Ooh, I think it works. Read battery data, read battery model, read battery data. It's working. All right, so what did we just make here? We took the Trinket M0 and we put it inside this case. I've seen some pictures of other people who have put the entire Arduino Uno. I can grab it, that have put the entire Uno inside the case, which isn't wrong. I just wanted to try this smaller solution. And if you guys are if you guys are keen on programming, you can probably figure out how to change the color of that LED. That's a NeoPixel LED, and there's guides and stuff on Adafruit's website. This is an Adafruit board. Adafruit makes a lot of cool stuff, not sponsored, but they make a lot of cool dev tools and stuff. I use a lot of them. And this Trinket is one of them that's really cool. It's nice and small. It's a 32-bit microcontroller, ARM-based. Anyway, with that, I think we're about done here. So sometime down the line, we'll get the next part of it, which is putting the software on here, so on the Raspberry Pi. But this should be relatively straightforward. Just install the Raspberry and the Raspberry Pi OS, put the Python thing on, connect it with the USB, but we'll save that for another video. So I'd like to thank all you guys for watching, and have a great day. We'll see you on the next one.